Hello, I'm Jan Dolzer, Product Manager for the Sutter Instrument P2000 laser-based micropipette puller. We are producing a series of instructional videos that demonstrate how individual parameters of the pull program impact the shape of the final pipette. Our ultimate goal is to give you an in-depth understanding of how each of the parameters affects the geometry of the pipette and what you need to change if you want to achieve, say, a shorter taper or a smaller electrode opening. This introductory video will give you a little general background about the P2000 puller and will help us understand what we see in those close-up videos. Let's take a look at the instrument. Under the tinted lid, the two puller bars hold and position the glass capillary. The shroud between the puller bars encloses the retro mirror, which redirects and focuses the laser beam to achieve even heating of the glass capillary. In our first set of video clips, we used 1mm thick wall quartz glass. Item number Q100-50-10. Sample program number 1 pulls a patch pipette with a short 4mm taper and a pipette opening of about 1 micrometer in diameter. We're loading the quartz glass capillary into the puller bar on one side. Bring the two puller bars together and clamp the other side. The lid must be closed, program 1 is selected, and action! Since you're watching this video, you've probably done this 2-3 times before. Therefore, let's now move into our laser safety lab and take a look at things the way you haven't seen them yet. In our series of tutorial videos, we will watch micropipettes in the process of being pulled from Premier seating. Viewing the P2000 puller from its back at an angle, the retro mirror is oriented like this. Zooming in from this perspective gives us an example of the diagonal view in which we get a good look of the retro mirror, the clamps of the puller bars, and of course the glass capillary. We will take a closer look from the same point of view, focusing on the glass capillary. Here the sequence again in slow motion. Quartz glass lights up when it's hot enough to be pulled, thus allowing us to easily monitor the heat distribution. Note how the hourglass is formed during the first heating cycle, and the glass separates very quickly during the second cycle. In another point of view we use in our videos, the camera is positioned directly behind the retro mirror, just above the axis of the laser beam. This is referred to as the parallel view. Most of the time in parallel view we will have the lights dimmed. This gives us a higher quality image of the heat distribution within the quartz capillary. The main objective of our tutorial videos is of course teaching you how to create your own pipette programs. In one of the first scenarios we will make a copy of program 1, which pulls patch pipettes, to program 71 and then vary parameters such as the velocity. We will discuss the impact of different velocities on the shape of the final pipette. In the example shown here, the length of the hourglass increases with the velocity. An important factor in being proficient at pulling pipettes is the ability to recognize and correctly interpret the symptoms of when a parameter has been pushed beyond its useful range for a certain type of glass. To learn this, we will take close-up looks at pipette tips pulled with appropriate parameter sets and compare them with pipettes pulled with parameters outside the reasonable range. Let's finish with a word of caution. The P2000 puller is a Class 1 laser product, which means in everyday operation the laser radiation is safely contained inside the enclosed housing. Redundant interlocks and other safety features reliably protect the user from exposure to the laser beam. To show pipettes while they are being pulled, we have produced the detail images in our videos using a specially modified instrument running under controlled conditions in our laser safety lab. The 10-watt CO2 laser in the P2000 puller produces an invisible beam that is powerful enough to melt quartz glass. That means it's easily strong enough to cause serious burns to your skin and especially to your cornea. We don't want you to get hurt, so please do not disable the safety features on your puller at home. What you should try at home, however, is watching our tutorial videos and experimenting with the program parameters yourself. A good microscope with long-distance optics helps tremendously monitoring the effect of a parameter change. If you need any tech support, go to www.sutter.com or give us a call at +1 415 883 0128. Enjoy our videos.